My name is Charles Furlan. I am the Vice President of Business Development for Nuage Networks. I'm normally based in California. That's our headquarters. I'm obviously here for a few days. Nuage Networks, really, we are a venture of Alcatel-Lucent. By the way, Nuage is the word in French for cloud, so cloud networking, so Nuage Networks. Being owned 100% by Alcatel-Lucent, being a French company, we had to put a French twist into this. So Nuage Networks, we're based in Silicon Valley. We have a team around the world that focuses on data center interconnect and branch office connectivity. And with the introduction of the cloud, the way we consume application and the way we connect our branch office changed significantly. And this is why we developed a certain level of abstraction and automation in the network that makes it easier to consume, and I'll talk about that a lot during this session. But really what is very important in the Nuage solution is the policy-driven approach here. It's not about, hey, I have a switch or a router, and now I'll make it a V-switch or V-router and say this is SDN. As a matter of fact, you might have made your problem even worse now because the amount of effort to configure routing protocols and networking protocol on a physical switch or a V-switch is about the same, right? But now you have a V-switch in every single server in your data center. So it becomes actually it actually become worse. So the importance of a policy-driven approach here is really to have a declarative mode to say, I want to have my web servers to communicate with my database server through a firewall, right? And that's it. That's how you have, in a very business-oriented way, my application 1 talks to application 2 via a firewall or via application 3 or whatever you define this relationship, and that's the job of Nuage SDN controller to go down and configure the right networking protocol. So we started shipping our commercial product mid of last year. We have done over 100 successful trials and significant proof of concept. We have over 25 wins in production, and this is not yet, they just purchased, but they're not really deployed. This is 25 accounts that we have in production. I'll talk about some of them, some of the European banks here that we have as reference with Red Hat, like BBVA and Santander in Spain. And we have some of the largest cloud service provider, Nuage in France, Evonet in Belgium, a smaller one, and then China Telecom Cloud Company. The entire public cloud offering is using Nuage, and I'll show you what is the value that we bring into all of this. If it's still possible to tone it down a bit, it would be great. Okay, so really all of these customers started to deploy some cloud, and they realized that a lot of the things changed from how they deploy their application on a physical server, and they would install the operating system on that physical server and connect that server to a specific part of the network, and that's where they would apply the networking configuration. So if this is a web server, they would call up the networking team and say, this is my marketing web server, and we would configure on that switch 5, port 6, here are my networking parameters that I configure and the security parameters for that physical server, right? But now with the with the workloads becoming virtual, right? With the virtual machines now, you gain a lot of flexibility. It's a lot more dynamic. You can spin up new virtual machine pretty quickly. But more important, you can also move them around. You can move them from one server to another. You can move them from one rack to another, and very freely. You gain a lot of flexibility. However, if you're still bound your networking configuration to the physical network, you don't take advantage of all of these benefits. You don't harvest them, really, because that networking security parameters that you configure on, when I say switch 5, port 6, when you move that virtual machine, that stayed there. So we need to change the networking profile to become as dynamic and as agile as the cloud is, and that's something that we call the networking shift. And we started to look at this and say we need to do the same thing to the network that what happened to the physical server. We need to create virtual network, and we'll look at 4 different components to do this. First one is we'll need to create a level of abstraction, meaning that however I'm configuring my networking policy or my networking security or SLA, it can't be bound to a specific equipment. It can't be only working with that Cisco switch or that Arista switch or that specific whatever, right? You need to have a level of abstraction that regardless of the network, your same policy will be applied everywhere, right? We'll need to achieve the same level of automation, the zero-touch provisioning that we have with the virtual machine. In a cloud environment, you can spin up virtual machine very quickly. We need to have the same level of automation with the network itself, right? Finally, we need to do this while applying control, the same level of control, either the security control, either it's a bare metal server, a bare metal server, a virtual machine, or a container, and provide visibility through all of that infrastructure, so that one thing that when we went in production, we realized is that while the networking guys are happy with their physical infrastructure, the overlay or the network virtualization team is managed by a different organization. So how can we correlate that so that when you're a customer putting this into production, if there's a problem somewhere, you're able to identify if it's on the physical switch or if it's on a virtual switch, where is actually the problem, right? So by network virtualization or abstraction, I'll give you the example of if you want to send me a letter, you would take an envelope and write on the envelope to go to Charles Furlan at Nuage Networks, Ravendale Drive, Mountain View, California, and that letter, that content would eventually reach my office, right? Because the address is physically configured to a specific location. If I'm here today in London, obviously I don't have access to that content. However, if you want to call me, if you want to send me an email, or if you want to send me call my mobile phone, I have the same address, the same email address, or the same phone number, yet I can take that address and move all over the world, and you're always able to reach me, because that address is tied to a device and not to a physical location. So that's what network virtualization is doing in the level of abstraction, is we're not going to configure the IP address and the access control list and the QoS and all of these networking settings on the physical switch. However, can make these parameters and tie it to the virtual machine, to the workload itself, right? So that when that workload, just like my mobile phone, roam the world, you move it from one data center to another, from one location to another location, it keeps the same networking profile. So that's the first level of abstraction that we want to do. And to give you an example is, in a scenario like this, if you would deploy some virtual machines, you would have to go to the physical network, the top of rack, or the blade switch, or the core switch, and enable the right IP address routing and the right VLANs. You have multiple connection points that you need to configure on the physical network, right? What we're doing instead is creating what is called a networking overlay, right? A network overlay is basically running on top of the physical network, and we create what is called VXLAN tunnels to connect these virtual machines with one another, right? We don't actually configure the physical network anymore. The physical network, when we talk to the networking guys, we just ask for, give us connectivity, make sure there's transport between A and B, make sure you have that connectivity, and we'll define the services, the policies that web server talk to database server through a firewall in the overlay, right? And here's an example is, for example, in this context, we have what we call the underlay, which is the physical network. We don't touch and change anything there, just as is. And we create virtual network using the SDN controller. And the virtual network, will assign some virtual machine to it. There you go, right? And we'll assign, say, well, that virtual network is only able to talk to other resources in that virtual network, is not able to do this and that. We configure the virtual network just like we configure pretty much a VM on top of an hypervisor. Here we create a virtual network, and we'll assign business logic policies to say that VM will talk to a firewall before talking to the other VM, right? And it just so happened that we encapsulate all of this in VXLAN tunnels, and we send this over the physical network. But the physical network there is absolutely not aware of any of that business logic running on top of it. So that's one beauty and one very simple use case is our customers are deploying Nuage as the end solution in a couple of servers, and they don't even have to change anything on the physical network. As long as you have a switch vendor that forwards Ethernet IP traffic, it will work. And that's a very important thing, that you don't have to forklift any of the physical equipment for this type of technology to work, because we're creating virtual network on top of it. So that's pretty much what we mean by abstraction, is we don't bind our new networking protocol to the physical equipment, but we attach it to the virtual machine. The automation is to achieve the same level of automation, and we work a lot with Red Hat to achieve this, is in a cloud model, you're able to deploy workloads very quickly. You know, you're within seconds or within minutes, you can assign 500 new virtual machine or virtual workload running pretty much instantaneously. However, when you want to have these workloads provisioned from a networking perspective, there's a lot of inefficiency that is introduced, right? On the left side, the application is provisioned pretty quickly, storage is attached to these applications. However, very often you need to configure to connect with a different team, the networking team, that will have to assign IP address, configure VLAN, add these workloads to the load balancing. Well, maybe there's some firewalls that needs to be configured. And while you have a lot of flexibility and agility to spin up new virtual machine quickly, the time it takes to configure the network is a different process, is a different team, and that is often days, weeks, or months to become active. So we need to change this and have the same level of automation that on the networking side that we have on the compute side. And we do this by creating the Nuage VSP, by inserting our Nuage VSP platform into most of the orchestration platform available out there. In the case of, we work a lot with OpenStack, right? We are certified in the OpenStack distribution, and basically what that allows us to do is the capability that when a new workload is actually created, these new marketing web servers are created, well, we are made aware of that, right? Through that plugin. We consult what we have, when I talked earlier, the policy templates that we have. So the network admin guys define these policies to say, well, that web server will be able to talk to that database server through a firewall, right? We pull that policies, and we, at the same time, automatically go and configure the virtual network with that declarative policy, right? So that when that virtual machine is actually enabled, the network, the firewall, the load balancers, the IP address, all of this is automatically configured at the same time so that you're ready to go. The alternative to that is people typically say, well, I'll put everything in the same VLAN, I'll put everything in the same network, right? Well, that might work, it obviously doesn't scale and has a huge security exposure, right? So this is how we apply the security templates into the provisioning of the workload at the same time. So that's our level of automation. And the second thing, the third thing that I mentioned abstraction, I mentioned automation, control, and visibility. Control is becoming very important, more and more important, the fact that we want to have our environment contained. We put a lot of effort in our security strategy to actually protect the perimeter of the data center. We put very efficient firewalls that control what's coming in and coming out. However, we did very little to protect the east-west traffic, the traffic between the application. There was a study, I think, by Gartner that showed that a malware, a server that gets contaminated, is contaminated for 205 days before it gets detected. So for 205 days, that piece of software, of Trojan or malware, is able to infect the rest of the network, the rest of the servers, right? What we're introducing by control in the Nuage VSP platform is a concept of micro-segmentation, is the concept of having reflective access control lists that will contain your application within the respective group, so that if one server gets contaminated, it's simply not able to go and spread around the rest of the infrastructure. So we're impacting that level of control, and we can go as low and as detailed as specific application on specific server, but now we gain a lot more control in protecting the east-west traffic in your cloud environment, right? And we can do this, very importantly, over any type of workloads. And that might seem evident, but we all think that, yes, we have, maybe our customers have virtual machine running on VMware or on KVM, but believe it or not, there's still a lot of bare metal servers out there. There's still a storage, AIX, mainframe, there's a lot of bare metal servers that need to be handled with the same level of control, right, as the rest of the infrastructure. And that is pretty unique to our solution in the context of providing the same level of control and security and policy engine. Either it's across data center, either it's containers, which is pretty hot topic at the moment, KVM, obviously, VMware, bare metal, and even now what we introduced is branch office, a way to seamlessly bring your branch office, the users consuming this application, into that overlay seamlessly. And if that application moves from one data center to another, we simply go and reprogram the VPN in these branch office dynamically, right? So finally, the last, wow. Okay, the slide got, so obviously visibility is not, I don't know if something went wrong on that slide here, but the important aspect here is that when we introduce the concept of overlay, we lose some of the visibility, as you can see. And that reason is that when you have a problem between virtual machine 1 not being able to talk to virtual machine 2, if you call the networking team and say, hey, my VM is not able to talk to my other VM, they'll simply say, I don't know what you're talking about. I don't have these IP address. I don't know where these virtual machines are. I'm just responsible for the network. So you need to have a way to correlate what you're doing in the application, network virtualization, with the actual physical network. And this is something that we are doing with a tool called Virtual Service Assurance Platform, which basically we'll use standard protocol to listen to the underlay, to the physical network, and we'll listen to SNMP, for example. We'll listen to the normal routing protocol, and through these industry standard protocol, we'll be able to discover and map the entire physical topology, right? So we know exactly what's going on the physical network. We also pair this, obviously, with our SDN controller, and we're also aware of these policies. So meaning, my web server has to talk to a virtual firewall before talking to the database. Well, if virtual machine is not able to talk to the other virtual machine, maybe because I have a policy restricting it, right? If not, then I'll look at the other layer. What's happening on the physical network? And in this context, what we'll do is that, well, there is a physical port error. So at one point in the network, there is a router that has a failed interface. And that so happened that it's the only link between virtual machine 1 and virtual machine 2 at one point has to transport through that part of the network, and we'll flag it in a very clear and simple graphical interface that there is a physical port failure on that switch, that port, and it affects all of these virtual machines. So you gain a lot of visibility to say, hey, I can now operationalize that and understand that my physical network, although it's running independent of all the policies that I'm applying on top, is still made aware of, in case of a failure, what virtual services are impacted. So that's really was the 4 type of pillar that we are building our SDN strategy. It's about creating a level of abstraction independent of any hardware, a level of automation that we go and configure through these plugins and templates, the network at the same time your workload is actually created, applying the same level of control and security filtering across all of the different type of workloads, container, VM, or bare metal, and finally having the visibility between the physical network and the virtual network so that you have an operational model that is efficient, right? So, and that is really the, some of our customers deploying our SDN solution are really looking at different trends of cloud being deployed right now. Some are deploying it in a private or public cloud where their business unit were simply renting some services on AWS, completely bypassing the IT environment, right? But then our IT organization want to have that same level of flexibility and agility and automation that AWS can offer. However, they don't have hundreds and thousands of software developers to do this, right? So a high level of automation and integration is needed here. In the case of our service providers, the telcos, are building NFV cloud. Perhaps you've heard the term before, right? Where resiliency is perhaps the most important concept that these guys are looking for, right? And finally, I keep talking about branch connectivity because the branch or VPN connectivity to the branch office is about to be completely transformed. It stands still for the past 2 decades where we build VPN, every branch office coming back to the headquarters, and that was pretty static. But now applications are a lot more collaborative. You have video conferencing between branch office. You have a large amount of files exchanged between users, right? Some of the applications are not all at a headquarters, but they're at Salesforce or they're at Office 365, right? And you need to have a way to dynamically address that connectivity in an extremely distributed fashion. So automated, resiliency, and distributed are sort of the trends that we're seeing in the type of clouds that are being deployed. So we looked at this and say, how can we solve these different trends, right? And we could have started from scratch and say, hey, here's how we're going to address that, and there's plenty of little startup that went down that path. We had at least the luxury to be a venture of Alcatel-Lucent and being able to leverage a lot of that intellectual property. So we looked at how we solved MPLS. How did we bring massive scale network, right, around the world to be so efficient? And we looked at how we did it in MPLS, and each time I add a new VPN MPLS customer, I don't go mess around with the core network. That would be terrible, right? The core network is left alone. And you do your service definition in what is called the MPLS PE router, the edge, right? And that edge is where you'll define that service definition. Well, that's exactly the concept that we applied at Nuage and say, well, if it was good enough for millions of endpoints in MPLS, I'll just use the network as a fast and simple transport, and I'll do my service definition in the vSwitch inside of the server. We looked at how we build the internet, right? And we say, it's not true that I can have a centralized database with backup database that will synchronize and try to stay synchronized over WAN link, or having a database here and another one in Hong Kong and expect them to be not affected by latency. That's not how the internet worked, right? The internet was built using a protocol called BGP, which federated one another. And if you can have a core router running BGP, you can have an administrative domain managing that part of the network, and they'll have a way to understand how have a full view of the entire environment through BGP federation. So that's how we federate our SDN controller, and we say, if it's good enough for massive network like the internet, surely it's applicable to us, right? And the third element that we applied in our concept is really how did we build mobile networks, right? And again, I mentioned the policy, and this is very, very important because we learned this from the mobile world. That I'm based in the US, I just landed here in the UK, I turned on my mobile phone, and the same address, my same phone number, connected to a network that is, I don't care if this is a network from a BT or whoever. I don't care if it's a Nokia antenna or Siemens or whatever. The physical infrastructure is irrelevant. It just provides me connectivity. However, the authoritative domain is AT&T passed down the policy to my mobile device to say, yes, it can do data roaming, it can pull down emails, it has access to voice roaming, and all of the policies associated with my contract got pushed down and applied to my mobile device. Well, that's the same thing that we apply, but not a mobile device, but a virtual machine. So when a virtual machine picks up in AWS or IBM SoftLayer or halfway in your resilient data center sitting in France, well, it contacts the authoritative domain and says, yep, that virtual machine is able to talk to the firewall before talking to the database. And we go and program the network the exact same way, seamlessly. So these are the concepts that we applied to build what is the Nuage and cloud environment today, is from the overlay from the MPLS world is when an hypervisor, there's a virtual machine that is connected, what actually happens is we'll go to the policy engine, just like we do for on the mobile world, and say, what are the policies that apply to that virtual machine? And in this context, we'll create the fact that we'll create VXLAN tunnels, the network overlay virtualization, that say, well, that virtual machine is able to talk to that virtual machine, and even down to the branch office, which more, you could have some application residing in the branch office, or that policy could seamlessly extend to a remote location like that, right? So, and if we want to federate the control plane, this is also very important, because now you could have an SDN controller sitting in your data center in London, hosted, load one, this is a virtual image, so you could have one in Amazon AWS, and you could have another SDN controller residing in your New York data center. And the federation is using BGP, the same as what we're doing in the internet, so it's extremely easy and stable to scale your environment. And this is what our customers, most of our customers, are deploying today. Very successful in deploying private cloud, where they'll use our architecture to build network overlays regardless of the location. Now, most advanced customers, the ones that are at the cutting edge of technology and the ones that are pushing us, are looking at something called hybrid cloud, right? And actually, according to IDC in this context, they survey enterprise customers to expect 65% of them to be in some shape or form working in a hybrid model by next year, right? And really, an hybrid cloud is the way to have, say, hey, you've built a private cloud on premise, that's fine. You also have public cloud offering, and you have some resources over there. And how do you have an hybrid, which is a cohesive or integrated view of all of these systems into one single cloud platform, right? So the reason why you would want to do this is perhaps to address disaster recovery. And this is one very important aspect, where some customers say, I want to have my private cloud. However, in case of a catastrophe, I want to use all of the workloads on a public cloud, right? But I want to have the same networking policies that was working for me here programmed automatically, right? Or maybe you have a peak in demand and you want to burst using some capacity in the public cloud. What we see very often is actually some of the financial institutions that gathers their information on Hadoop. They will have very specific, very short period of time where they can rent by the minute and say, hey, I want to crunch some data on 500 workloads, and I don't want to buy them, I'll rent them on a public cloud. Now, when you do this, you still want to have the same networking policy, and this is what we bring to the table. This is the same networking configuration, just like I gave you the example of my mobile phone has the same number no matter where it is. These workloads, either you have them in your private cloud, or either you have them in the public cloud. Because we're using a very straightforward federation using BGP for our control plane, our SDN controller, that workload or these VMs, when they're enabled on a public cloud provider, they contact the same policy engine, and we go and program this and enforce the same security rule just as if they were on your premise, right? So this is where we're starting to have a lot more interest. A few of our customers actually rolling this out. One of them being, and this is what we're doing a lot with Red Hat, right? We are certified and integrated into their platform, right? We work with, obviously, CloudForm. We're integrated into OpenStack and the virtualization, enterprise virtualization strategy. And the hybrid cloud, obviously, we provide a networking connectivity into that context, but there's a lot more. There's some storage, there's some workload that needs to be aligned, and this is where we work very nicely and integrated into a Red Hat solution. So one of our customers actually in Europe is starting to look into this. BBVA, which is a big bank in Spain, actually deployed Nuage with Red Hat on their premise, right? They're also one of Google's top customers for some services, and they're also looking at hosting some workloads into some public cloud like AWS, right? So the capacity to move workloads or application from on-premise to off-premise, keeping the same networking profile, is extremely important for them, right? More important is the European Central Bank is also imposing some high level of governance on these banks, right? And you need to be able to prove or to provide a clear audit that that security policy was applied to that workload at that time by that person. Oh, was it on premise or was it on the public cloud? You still need to provide that same integrated audit trail. And this is what we do by correlating all of that events into a single Hadoop cluster, and we can provide that very nicely. So this is a BBVA, just to and when some of our banking customers are looking at some of the advantages here, because we're using the template, right? Because we're using the template and the network is configured seamlessly, the network administrator does that template once, and each time that virtual machine is spin up or created, well, that template is invoked and the network is programmed accordingly. They're able to reduce by half their operational costs, right? They're able to bring services 10 times faster, right? Because now I don't have to wait for the networking team to give me the IP address and configure a load balancer and all of that. That is done at the same time. So 10 times faster to bring their application to the market, right? Another example is Santander, which is, again, a very large international bank based in Europe, where they estimate that a fifth of their business can actually be going to some of the digital bank. So they need to change how they do traditional banking from brick and mortar to have sort of a virtual environment. And they're adopting a very agile, DevOps type of approach to have a faster time to market, to all of the benefits that you associate with DevOps, and to put this into production so they are able to reach mobile banking, new users and all that. So what they have, actually this was a couple of months ago at the Red Hat event, where they published their architecture and said these are the components that they are actually building their cloud offering. Right? They obviously use a lot of Red Hat component, and one of them is the Nuage to do the networking, right? We augment the OpenStack Neutron module, right, into that architecture. And we augment it in many ways. We provide a lot of advanced capabilities that Neutron simply doesn't have. For example, the distributed routing. So instead of having a Neutron router that will process all of the routing, we're able to distribute this inside each of the vSwitches, inside all of the servers. So that if one virtual machine needs to be routed to another virtual machine, we can do this directly inside of the server and not wasting any bandwidth on the network. Right? If, for example, we also want to implement some security, and this is extremely important, and probably one of the most significant reasons why our customers are deploying us, is the capability to enforce, as I've mentioned, these templates, say, hey, I don't want any of these applications to ever talk to any of these other applications, right? And the capacity to go and program this inside of the vSwitch, inside of the server, provides a high level of security and a strong peace of mind to our customers. So also another example where we augment the Neutron platform is providing the multiple cloud management system. And this is, yes, sure, OpenStack is extremely important. However, they might have something already in place. They might be going to a different cloud management system. And having the exact same networking profile, regardless if it's provisioned by a VMware orchestration tool or an OpenStack, is also something extremely important. And finally, I'd say the scalability of the control plane. And in some ways, what I mean by that is the capacity to turn up to program the virtual network very quickly, right? So I talk about, hey, we pull down the template and we go and configure the virtual switches and all that, right? The capacity to do this extremely quickly is becoming increasingly important. In standard open source software, we're saying that can take a couple of seconds. That might be okay in some cases, clearly not okay if you're going in production, clearly not okay if you're looking at containers, right? Containers, the average lifetime of a container is far less than an hour. I'm talking with we're working on a project with a large search engine. They're telling us the average lifetime is 500 milliseconds of a container. So, boom, they spin up a bunch of container, assign it to a task, and tear it down. If you take a couple of seconds to go and program all the virtual network element, it's too slow, right? So the capacity that we have here is really to, and here's it's actually on YouTube. Our CTO, I think, sort of show off it a little bit, but he spin up 20,000 containers with 140,000 access control lists, so the security policies that that I talked about, and did all of this within 8 minutes while renting some services on Amazon AWS, right? So it's not as if we had the hottest server in our house and fine-tuned. No, we public cloud, AWS, launch that, and he's talking while these are activated in the background. So the capacity to scale is increasingly important on your control plane when you're actually talking about containers, and that will be extremely important. So the Nuage networks, what we actually sell, what's our product actually, and what we integrate with Red Hat, is actually 3 software part. Right? The first part is the VSD, which is a virtual appliance. All of this is software, right? So the virtual appliance is the policy engine. It's really where you define your policies. You say, my web servers will talk to my database server through a firewall. You define this over there, right? We split up that's the management plane, and we split up the control plane to say the control plane is actually the SDN controller that will take that policy and say, well, okay, fine, web talks to database. But obviously, that means there need to be some IP addresses and all of that configured. It's actually the responsibility of the SDN controller, the VSC, to convert these policies and go and program what we call the VRS, the virtual switch, residing inside of the server, and say, well, that IP address, I'll build a tunnel to that other IP, to the firewall, and I'll build another tunnel from the firewall to the database, right? So that's really where we're controlling, where we're actually going and programming what we call the data plane. And if we need to have more capacity, we simply add more SDN controller, more VSC, and they automatically federate with one another through BGP. And you need more capacity, add more controller, and they scale linearly, right? With no performance impact. So finally, bare metal, I keep telling about that. It's extremely important. We haven't done a project that does not have some legacy servers that need to be participated into that overlay, right? And having a solution that says, yes, this is very good. I have all of these policies, all of that integration and automation. However, I don't have any, I still have my legacy that I can't participate in. What we're doing in this case is we connect that to a top-of-rack switch, and our controller goes and programs that top-of-rack switch to say, well, these physical servers are actually participating in the same shape or form as these containers or these virtual machines, right? And finally, I mentioned the NSG, which is really our branch office connectivity. So 3 virtual appliances. We have the VSD, define the policies, the VSC, which is the SDN controller, and the VRS, which is actually the physical, the virtual switches, right? And we map this obviously into a Red Hat context where we are certified into the Linux, enterprise Linux distribution, right? And we have been for many releases so far. We also integrate that, I'm trying to map the portfolio here with some of the Red Hat product, is obviously in the OpenStack platform as well. Think OSP 5, 6, and now 7 is supported and integrated with Nuage. So our plugin, our integration is already into that distribution. All right? We finally also have an integration of professional services. I would say that so far, most of our engagement led to some professional services that Red Hat is delivering. And we have developed a joint offer where Nuage professional services and Red Hat are working together, so for that you guys, you don't have to have separate engagement in this context. You know, we have developed a joint offer for Nuage and Red Hat to deliver your cloud project, private or public cloud project seamlessly, right? So really, when I look back at this and say it's really a journey, the SDN journey is extremely important. And what I mean by this is that foolish you would be if you would go and deploy SDN tomorrow and say, I'll do everything SDN now. It doesn't happen like that, right? Most of our customers deploy SDN in part and gain more value over time, and as they're getting more comfortable. Most of them start in the data centers and say, fine, I'll create these tunnels between the vSwitches in the data center, and that's fine. And that's using the Nuage VSP platform, but it's the same VSP platform that maybe a year from now, they'll say, well, I want to move from one data center to another data center, or I want to migrate 2 data centers together, or I want to use an hybrid model where I have some resources hosted on AWS. And again, it's the same Nuage VSP platform that was doing your tunnels and all that in the data center that is now able to do your data center interconnect or your hybrid cloud deployment, right? And again, I think extremely important is branch office connectivity. Because now that you have these applications mobile and moving around from one data center to another, you need to have an integrated way to program your VPNs, your WAN, to say, well, these branch office have access to this data center for these applications. And if you move this application, we'll reprogram the VPN. So that all of this, through the WAN, branch, and data center, has the same SDN framework, right? And this is pretty common, but what is not common is somebody deploying this all at once. They're starting in some different area, but it's the exact same Nuage platform. So if you bought the SDN controller, you can use it in the data center or between the data center interconnect or the branch office is the same platform, right? So I'm reaching the end of the session here, maybe with a couple of words, is we have worked very hard and very closely with Red Hat to have an integrated solution on the Linux and OpenStack environment. We're working with CloudForm and OpenShift as well to integrate our technology into these platform as a service, right? We're enabling private cloud, we're enabling public cloud if you want, and hybrid cloud in the sense that we're able to augment the security. That's perhaps one of the biggest reasons why we're deployed, is the capacity to secure the traffic inside of the data center between the workloads, right? Like nobody else can, right? The capacity to have these virtual machines move from one location to another. And that is something that vMotion, for example, gave us on VMware a tremendous amount of flexibility and mobility to move a virtual machine from one server to another. However, the network was still physically configured. So now we're able, because we have virtualized the network, these networking policies and profiles and SLAs and security net profiles are tied to the virtual machine, and it follows it no matter where it lives, right? And finally, increase the performance because we're able to do distributed routing, because we have optimized programmability of the data path is a lot faster, right? As I said in some of the example of the banks, they were able to reduce their operational cost by half, right? They actually, turns out that they use less equipment, so they have a better CapEx model as well, right? And most important thing than the OpEx and CapEx saving is the time to market. They're now able to bring a new application to their users at the same speed that they can deploy a workload and not having to configure the network manually. And that's a tremendous competitive gain that they have over the market. I think we're pretty much on time. I'm happy to take some questions now that I'm on the spotlight. So if there's any questions or comments. Otherwise, we do have a, yeah, there's a question here. Yeah, please. Yes. It's a pale attempt to do what we're doing, yes. Couple of differentiators. It is competing with NSX. However, NSX is data center only. As you can see here in an hybrid cloud model, we can deploy the technology no matter where the location, not just in the data center, but across multiple data center. And the correlation with the underlay that I talked about when about visibility, extremely important, right? But yeah, it's something similar. Okay? With Red Hat Virtualization, absolutely. We're working, yeah, exactly. Now in OSP, in Linux, we're working with the enterprise virtualization tool, OpenShift, and CloudForm as well. What do you mean by that? No? There was another question over here, sorry. Yes?
One of my concerns is around security.
Yes?
One of my concerns is around security. Obviously, you've talked about that. What kind of assurances have you had from, let's say, security bodies to say, you know, it's got the stamp on the box?
So that's a good question. And sometimes the customers with new technology, they look at this and say, hey, SDN is new. I get that you can enforce a lot more security, a lot more easy in the infrastructure, but how secure is the SDN infrastructure to begin with? And that was a concern of one of our large customers who forced us to do a third-party audit here, right? And they hired a third-party hacking company, security company, where they review the architecture, they review the source code, they try to do penetration tests, they try to do all of that during 6 weeks. And they published a report that we can share with some customers that, you know, we passed with flying colors. And when you think about it, the reason why we passed is that we use the same core routing engine that Alcatel gave us to build our SDN controller, and that core routing engine is enabling all the telcos of the world with their routing platform. So it's something telco grade that we have adapted. It's not open source, simple thing that we have put together. This was traditional telco grade that we adapted for the SDN context. Okay? Thank you. If there's more questions or comments, obviously we have a booth upstairs, and I invite you to come and have a chat with us, and we'll be more than happy to take your questions. Thank you.